Hello and welcome to our channel. In this video, we will be walking through our application note API interface, AN-10, to show you how easy it is to connect to one of our short-range radar sensors and start displaying speed or range information. Be sure to check out the link to the full application notes in the description box below. The topics we will be covering in today's video are a description of the two types of radar sensors we produce, how to connect and configure an OmniPreSense radar sensor, the default API settings, and lastly, examples of how to use the API to make changes to the output format, filtering for speed, range, and magnitude, as well as other changes. OmniPreSense provides two different types of radar sensors, a Doppler radar sensor and an FMCW radar sensor. The Doppler reports motion, speed, and direction, while the FMCW radar reports range. The feature differences for these sensors are shown in this table. You can also see here that several of our radars have full FCC or IC modular approval. This saves you time and money from having to get regulatory approval yourself. Instead, you only need to use our FCC or IC number for your product. Over time, you'll see us add more radar sensors to our product lineup with even more enhanced features. The main components of the board are shown here on the OPS241A short-range radar: a transmit antenna, a receive antenna, a 24 GHz RF front end, down-converted IF signals both I and Q, an ARM Cortex-M4 processor, and a micro USB over which the simple API communicates. Our sensors also support API communication over a UART interface. Power is supplied via the 5V from the USB or a separate power connector for UART operation. Now that we've looked over our radar sensor, let's power it up and try it out. Step 1 is to connect a USB micro to your sensor. If you were going to use the UART interface, you'd connect the 5V power, ground, and TXT and RXD lines. Then we're going to connect the sensor into the USB port of your PC or Mac and start a command terminal. A simple command terminal can be used to control the module operation with the API commands and visualize the output data. On a PC, TerraTerm is convenient because it can detect the active COM port, so when the configuration window appears, simply select the serial option and click OK. Alternatively, you can use PuTTY, Minicom, or Screen, as we can work with any PC, Mac, or Linux system. Once connected, the data reported by the sensor will start streaming to the terminal when an object in motion appears for the Doppler radar, or there's an object in the sensor's field of view with the FMCW radar. The negative numbers and the blue LED indicate an object moving away from the Doppler radar sensor. The positive numbers and the red LED indicate an object moving towards the sensor. You can simply test this by moving your hand towards and away from the sensor. The default settings of the module are set up to provide solid performance over a wide range of applications. Default settings can be grouped up into 5 general categories. 1. Output units. 2. Sample rate or sample size buffer control. 3. Output format. 4. Filtering capabilities. And 5. Power control. The default output units are the velocity or range values set at meters per second or meters. The sample rate and sample size buffer affect how fast we can report the data. The default for the Doppler radar is 10,000 samples per second with a 1024 buffer, while the FMCW is fixed at 320,000 samples per second and 512 buffer size. This results in a report rate of 6 to 8 Hz and can be increased to over 100 Hz. This can also be used to tailor for specific applications. For example, you'll want a 2 times faster sample rate if detecting fast car speeds. The default output format is a simple ASCII value. Other formats are available, such as JSON. You can report additional information such as timestamp, signal magnitude, or multi-object report. If you're at a university doing radar research, the API provides you access to the raw ADC data or the post-FFT data should you want to process it yourself. The API provides a flexible way to filter the reported speed, direction, and range. The signal magnitude filter for the Doppler is set at capital M is greater than 10 and M is greater than 150 for the FMCW. We'll discuss the filtering capabilities in more depth a little bit later. Power control deals with both transient power control and sensor power consumption control. In the default mode, the sensor is fully active with no power savings turned on. Transient power is set as maximum, but can be reduced if you'd like to control the size of the field of view. Now that we've gone over the basic settings, let's look at how we can configure them for specific applications. The API is really flexible and can be tailored to your specific applications, depending on the environment and objects in motion. The API commands can be set by typing into the command terminal to change settings on the sensor or control its operations. Let's go over a few examples of the commands. Type !** for module information such as the product number, sampling rate, sampling size, and so on. If you wanted the velocity units in miles per hour, simply type US. Another useful command is OT to provide timestamps for your data. The time is reported in seconds and milliseconds since the sensor was first powered on or reset. The full list of API commands are all included in the AN-10, and there will be a link in the description box below. A powerful feature is changing the API settings to filter out the data reported. You can get a minimum or maximum value for speed, range, and signal magnitude. If you look at the graph, Doppler radar sensors can be filtered on speed with capital R greater than N or R less than N, signal magnitude with capital M greater than N or M less than N, and direction with R+, R-, or R vertical bar. For FMCW radar sensors, the data can be filtered on range with small r greater than N or R less than N, and a signal magnitude small m greater than N or M less than N. Here's an example of setting the speed filter to only show values which are greater than 1 meter per second. If I move my hand slower, no data is reported. An interesting usage for filtering is if you wanted to use the sensor as a people counter, you can set the maximum speed so that the sensor does not pick up objects moving faster than a person would, such as a car passing by. Similarly, you can set a minimum speed to filter out people walking if your aim is to track cars on the street instead. And that's it. Our radars are designed to be very easy to connect and have a very simple API to give you a lot of control over their operation. Now that you've learned how to connect and configure an OmniPreSense sensor, try it out for yourself and see how easy it is. Please be sure to tag us on our social media if you try this out. Subscribe to our channel for future videos on more application notes and OmniPreSense. Thanks for watching.